Hey all, so today I'll be talking about a little project I did using Nerves, a Raspberry Pi 0W and a temperature sensor. It came about because recently I've been getting into brewing beer, and as part of that process, temperature becomes quite important with fermenting the beer. You basically start off with extracting sugars from grains by boiling. You add some hops to add a bit of flavor. And then you cool it down, you add some yeast and you let it ferment for about 2 weeks, at which point the yeast turn the sugars into alcohol. And different yeasts work at different temperatures. And if it's too hot, potentially the yeast become too active and they can add some odd flavors to your beer. Also, if it's too cold, they can become sluggish or even die, and fermentation will stop. My first batch turned out pretty well. I did it pretty blindly. It was a starter kit, and it was an Australian pale ale, which ferments between 18 to 24 degrees. That's a pretty easy range to get to, but other beers like lagers need to be fermented at a slightly lower temperature, around 12-ish degrees. So I thought that it would be good to be able to monitor where I'm putting this, the fermentation bottle, and be able to potentially trigger something that could either heat or cool the environment. It's been cool exploring something that can have a practical application. The basic goals of the project is to see a history of temperature readings over time, be able to place the sensor in any location at home and get readings wirelessly. I've got here, in place of a cooling or heating device, I'll have an LED that will trigger on and off. I looked into solid state relays and I'm not quite confident in connecting one up to mains power yet and triggering it on and off. So I need to do a bit more learning around that. To get started, this is the hardware that I'm using. So we've got the Raspberry Pi Zero, which has wireless capability, the Bosch BME280 sensor. You'll also need a SD card and reader to burn the firmware on, a USB cable, LED, breadboard, wires, and resistor. And these are just the connection points from the Pi to the actual sensor. And I'll be using Nerves. Using Nerves because it comes with pretty much everything you need to get up and running with a hardware project. You get a bunch of modules that will help you with connecting to network, doing logging. There's tooling that will enable you to update your firmware via a USB cable or over Wi-Fi, even SSH directly into the device to do troubleshooting or run code. And this is just a closer look at the temperature sensor. I'm using a library that was built by Frank Hunleth, who is one of the members of the Nerves core team. I'll just go through how you can get started with Nerves, and then I'll go into the project. So to get started, you'll need to install Nerves on your laptop. The documentation is really good. So there's all the installation steps there. You'll need to install Erlang and Elixir, and then a couple of other things, and then install the Nerves bootstrap. And once you're installed, you can get up and running by creating a Nerves project by running mixnerves.new, followed by the name of the project. And once you've created that project, what you can do is add the BMP280 library to your mix.exs file and install your dependencies. Before you install your dependencies, you should set an environment variable as to which device you're using. Here I'm using a Raspberry Pi, so I've run export mix target Raspberry Pi Zero in my terminal. What I'd also suggest doing is creating a .m file in the root of your project and adding your environment variables in there, and then sourcing that file before running the mixsteps.get. And what we're doing here is then burning our, creating an image which shouldn't take too long. And at this point, we've got our image ready to go. The next step we'll do is configure our wireless configuration. So the Nerves comes with Vintage Net, which does all the networking for us. So what you will need to do is update your config file and set your environment variables for your network name and password. And here I've also got the target here in the .m file. And finally, what you want to do is set up over-the-air firmware updates. What that means is you don't need to continually eject your SD card and plug it into your laptop, burn the firmware, and then put it back into your Raspberry Pi. You can, if it's connected to the network, you can upload that over the air or via the USB cable. And you do that by generating a shell script. And what this upload shell script has is it detects the network. Its default is nerves.local, and then it looks in the images folder for the firmware file, and then it uploads that. And once that's all done, burn your SD card, plug it into your laptop, mixfirmware.burn will automatically detect that SD card. It'll prompt you as to confirm that you want to burn the image onto that SD card. And once that's done, it automatically ejects the card and you're ready to put that in your Raspberry Pi. Once you are up and running, you can check to see. At this stage, you would be probably still connected via the USB cable, just so you can confirm that the network is connected. So you can check by pinging nerves.local in your terminal. And once you do get a response, you can SSH into the device and run code directly, and also run logging. And this is how you do that. You get a toolshed, which has a bunch of functions that can help with networking. So you can ping, provided you are connected to the network. You can do a DNS lookup. You can see the uptime of the device. There's also a logging tool called Ring Logger, which helps with troubleshooting. And Ring Logger, there's two functions. You can say next, which will just output all the logs up until this point, or you run ringlogger.attach, which will then follow the logs and monitor them as they go. And finally, this is just a video of updating firmware over USB cable or Wi-Fi. So at this point, you may have made some changes to your code and you want to upload that. So you would run mix firmware and create a new image, run your upload script, and here it is uploading over your network connection. So after all that, you're ready to get started with reading temperatures. This is a copy of what's in the docs. So you start a connection and you get a reference, a process here, and you use that process ID to receive a measurement. So it seems pretty straightforward. So I copied and pasted that into my terminal and ran it and got a big error. And looking closely, there's a couple of things that I don't really know what they are. So the bus name, I'm guessing that's the I2C port. The bus address, I don't know where that number comes from. So at first, I thought that was the issue and looked into how I can find out what the bus address is. So confirming the bus name, I can see here I2C1 on my Raspberry Pi pinout sheet. I checked my wiring and made sure that everything was in the right place and it all looked pretty good. I then wanted to find out how I can see what the bus address is. And the way you can do that is via circuits I2C, which comes as a dependency of the BME BME280 library. And there's a function on there for detecting devices. And so by running that on my device, I could see that it's not actually detecting my sensor at all. So after looking at my wiring again, I thought I might check my dodgy soldering. It's my first attempt at soldering something pretty small. And so I thought I might just retry my solder. And that was the issue in the end. This is a close-up of my dodgy soldering. This is actually after resoldering it and clearly need a bit more practice. But after running detect devices again, I can now see that it's detecting my sensor and this is my bus address. And it is the same. So running it again, I can now get a temperature coming back. Next steps is I want to introduce a UI. So I want to see my temperatures in my browser. And to do that, I'm using Phoenix Liveview. The setup that I'm doing here is a monorepo. So I have a firmware application and then I create a Phoenix Liveview application and then they're separate. And the way they connect is I add the UI, the Phoenix Liveview app, as a dependency to my firmware app. The reason for that is you don't need to do this. You could set it up as an umbrella app, but some of the reasons are that you can create have this dependencies separate. So you might want different versions of dependencies and also with configuration. And if this was in a production environment, people could work on the business logic side of things and the UI separately to the hardware side. There's a few steps to set up the live view. There are really good instructions. I've left some links here. This talk will be up in my GitHub as well. But once that's all set up, we're ready to use live view to view the temps. So at this point, I've uploaded my firmware again to the device. So in the router, when we visit the home page, this will then call this mount function in our live view module. And what we're doing here is just polling every 3 seconds to run that same function to read from the sensor, update our socket, and then in our template, we're displaying each of those measurements that were returned in that struct. And here's a video of what that looks like. And so that's pretty cool. So we've got something working and I'm feeling pretty comfortable with the sensor. But what I really want is to see monitor the temperature over time. So the next steps were to not have my live view module talking directly to the sensor. I set up a Genserver. So this is a rough layout. So I've got a process here that takes care of talking to my sensor. It also sends that data to another Genserver, which takes care of the data side of things. And this then publishes, broadcasts the data using Phoenix PubSub, and my live view module subscribes to that. I'm also sending a post request to an external DB, which I'll get into in a bit. But in summary, my sensor Genserver starts a link with the sensor, polls every 5 seconds to get a reading. It sends that temp data to my sensor data process. And this also triggers the port to turn on and off. So in this stage, it's the LED, but that could be a heating or cooling element. And my sensor data, it creates a queue and a count. I just added a naive retention policy to handle how many items I want in my queue. So it adds and removes data. It broadcasts that data via Phoenix PubSub, and it sends that data to an external DB. For persisting data and visualizing, doing a bit of Google, I found Context, which is a pretty cool library, which has a set of graphs. I also came across a DB called InfluxDB, which is a time series database. It's open source, so you can download it and run it locally. There's also enterprise paid plans. But what InfluxDB does is it gives you a UI to visualize your data, which is pretty cool. To To set up InfluxDB, there's some pretty straightforward instructions. So you download it, and then you run the influxd command and you start up your server. You will need to create a token. Let me just go back here. So once you start up the server, you'll log in, and I'll show you the UI in a second. You'll have a token that you can get. Here I'm setting my local, my IP address of my laptop. You have an org that you'll set up, and then you can create buckets where you want to store your data. I'll just quickly bring up the code here and step through the Genservers. So here we have the sensor Genserver, and anyone that's new to Elixir, a Genserver simplifies how you interact with processes by starting the processes, updating state, and they're also supervised. So if they do crash, you can have certain policies to restart the processes, and also there's different supervision strategies that you can put in place as well. I've gone with the default on all here, so it's a 1-for-1 policy, and it's the default I think is permanent, so it'll always start up the process. Here on initialization, again, we're starting that link. I'm also opening the GPIO port 18, which is where I have the LED connected. And then I'm doing a polling every 5 seconds to read the sensor. I've got a couple of functions here to handle the sensor read. If there is an error, I'm just capturing that here and then rereading the sensor. And this is where I'm pattern matching to grab the temp data. I'm just added a couple of logs here and added a couple of guard statements. These are currently hard coded. So saying if it's more than 23, that's cool, like let's turn it off. If it's under, let's turn it on. And then finally that calls an add data function from the sensor data Genserver. This handle cast has quite a bit in it, so I need to do a bit of refactoring, but what's happening here is on initialization, I'm using a Erlang queue, which is a tuple with 2 lists, and setting an initial count of 0. And I'm incrementing that count every time we get a new data coming through. And when it gets to, when it's greater than 10, I then remove the oldest item and then add the new item. And then I broadcast the message here. And all this is the InfluxDB request. And this is what we send to InfluxDB. It's raw data, it has a timestamp, it has the temp value. We have a host, so what we could put here, I imagine it is you could have multiple sensors. So here I've got Pi 1, you could have Pi 2, and when you go to the UI, you'd be able to filter and view the different values, and then the measurement here. And with the Liveview, that's been updated now just to subscribe to that broadcast message. And we're grabbing the queue, I'm flattening that out and then assigning it to the socket. And what that looks like now is this. Styling still to come. What this is here is just a small example of using context, and it's called a sparkline graph. But what I'll do is start up the InfluxDB server. And let's have a look at that. Cool. And log in. And so this is where you can create buckets. You have an explorer, so you can create different queries. And there's different graphs that you can choose from. Let's go here. You can also create dashboards here. So here I've got one set, and which is pretty cool. You could also set alerts. So you could have a notification maybe being sent when you get to your ideal temp, and that could go to any endpoint. There's Slack here, PagerDuty, or any other endpoint that you want to create, and then you can set notification rules here. So what I might do is just show you the setup and try and get the light to trigger. Might be, let's see, I'll just go into the device. So at the moment it's over 23, so it won't trigger. But hopefully, let's see. Hard to see. I think that's a bit blurry. Oh no, maybe. Okay.
Really I think it's trying to do your some sort of background filtering.
Yeah, like, I should turn that off. Hey?
Yeah.
Where's? I have a video. Let me just. I'll play the video. So anyway, the idea is that I've just got a bit of ice here over the sensor, and so it's dropping the temperature, and once it gets under 23, it'll trigger that port, and the light will come on, and then when I take that ice away, it'll gradually go back up again, and the light will go off. So that would be maybe a cooling element there that, yeah, if it gets to a certain temperature, yeah, it's good. So yeah, this is the sensor setup I've got in my laundry. Looks a bit like a crime scene photo, but yeah, so this is the place where I am fermenting beer. And so with my next batch, I'll be able to monitor what the environment's like, see how I go with the solid state relay setup and having a heating cooling element, depending on what type of beer I'm brewing next. But next steps, I want to be able to persist data locally. At the moment, it's just held in memory. So yeah, if the process, when it shuts off, I lose that the last couple of readings, or if it stops sending to InfluxDB. So it'd be good to have some sort of cache persisted to the device. Look at setting up notifications. Yep, learn more about connecting a solid state relay. And then, yeah, use it to monitor my next batch of beer. And the talk is up in my GitHub, and the repo as well is there for the project. Thank you.
That's awesome. Is it time for questions?
It most certainly is time for questions. If you are asking a question, if at all possible, please turn your camera on so the speaker can see who you are, and the video can as well, if at all possible.
Hello. So just a quick question on the temperature sensor.
Yeah.
That's just ambient temperature, right? Is there a way to plug in like a probe so you could put it in the beer?
Yeah, I'd need to buy something separate, I think. Yeah, it's just it's just the ambient temperature. So yeah, it'd be good to have something that could go in the actual beer.
Cool, thank you.
Hey Fiona, nice one.
Hey.
Yeah, I just had a question. This is not really related to the project, but when you do get to the point of putting it in beer, would you need multiple sensors? Do you know, based on whether it'd be hotter or colder up top or down below?
Yeah, look, good question. I'm not too sure.
Yeah,
I know that looking at just been watching a bunch of homebrew channels, they generally just have one probe sensor going in. And there's yeah, and there's the main one they use is called a Inkbird, and it's exactly that. Like you put the probe in, and it's got a power board, and you plug in your heating and your cooling device, and it triggers one or the other off.
Okay, cool. Oh, nice one.
Thanks.
So I could potentially weigh in here a little bit. I don't have experience in homebrew, but I do have experience in cooling fermenters that have 300,000 litres of beer in them. And you can get away with a single sensor. It's not ideal, but you can do it. And usually slightly lower down in the vessel is better, and definitely as far away from your cooling element as you can. But yes, even industrial scale brewing sometimes will use just one temperature sensor because it's too expensive to drill holes in tanks that size to put another $500 sensor into it. But yeah, so I think you should be right.
Yeah, cool.
I have a very curious question. How long it took you to do the project?
Yeah, look, I've been doing it on and off since before Christmas. I've probably spent most of the time the last 2 weeks in actually focusing and putting it together and thinking about how I want it set up. You know, originally it was like, cool, I'll just have a live view and that'll just poll it and that's all good. But, you know, it was just kind of thinking about visualizing that data and storing it. And that's kind of like the last week or so, just learning about that.
Okay, thanks.
No worries.
Hi, Fiona. I've
Hey.
got 3 questions for you. The first one is about the alternatives. If you test something before in terms of hardware and software, or you just went straight to nerves. The second one is if you have found some limitations in the hardware, especially for the 0W. And I just get curious about the upload shell. What is the strategy that you are using for updating the firmware?
Yeah, so so with the, sorry, what was the last question?
The last one is about the updating the firmware.
Okay.
I know you can just push through the network, but I don't know if you are using something different or just pushing through the shell script.
Yeah, okay. Yeah, no, I'm just using the default script that's generated. In terms of the first question, I haven't done anything else, any other hardware, so I don't have any strong opinions. I've found Nerves really easy to get up and running. I'm pretty limited in experience with hardware and just kind of been dabbling with it. So I feel like it's a really good way to start with, but yeah, I need to rebuild it in maybe something else. And so I can get a bit more perspective on the differences. And in terms of limitations with hardware with this particular project, I haven't encountered any yet. It's a pretty small project, so yeah, it seems to work fine.
Thank you.
No worries.